All right, today we're going to be looking at log properties and models. I'm just going to go over the highlights of what you need to know as far as solving problems in this section. So I'm skipping over to page 5 of Learn, properties of logarithms. So a log is just log, or it could be natural log ln. We'll see both. You will be given some base, a. If there is no base given, it's understood to be 10. So that is saying if you just see log and then you have some number that you're evaluating, let's say 4, this understands that the base is 10. That's normal. That's like the understood setting. Okay, so if they don't write a base at the bottom, it's understood to be 10. Otherwise, they will have to tell you what base they want you to evaluate with. So if you have multiplication inside of your log, you can separate them or extend this and write two separate logs as addition. So it's kind of like the property of exponents. So you know how if you have like a x squared times a x to the third, okay, property of exponent says you would add those. When you multiply, you add. So this becomes x2 plus 5. Well, that same property is very similar, except it goes the other way. So if you have, well, it's actually the same. If you have log, let's say, of 2 times x, for example, you can rewrite that multiplication as addition. So it's almost the same as the exponential property. You can write it as log of 2 plus log of x. All right. So that's what this first property is saying. Then you have a division property. So if you're dividing, you can write that as subtraction. And again, that follows the same as the exponential property. And then this last property says if you have log and you're evaluating some number that is raised to a power, that exponent can simply be written as a multiple. So you can bring that exponent down to the front and write it as a multiple. So that's saying if I have log, let's say 5 squared, that would be the same thing as taking this exponent and bringing it down to the front and just writing 2 times log of 5. Okay, the 5 stays, the exponent just comes as a multiple. And those will give you the same number if you evaluate them in the calculator. They go through a little proof of showing you some of the properties and then some things to be careful of. So note, there is no property that says if you're adding within the log. Okay, so you did have a property that you can multiply and you can write addition of 2 separate logs, but this is not the same as x plus y and then separating it to log x plus log y. It only works when you have multiplication and you don't write the multiplication as 2 multiplication logs. Division, you don't write log of x divided by log of y is equal to this. It has to be 1 log with x divided by y to separate it. So these are like some common mistakes that happen that I just want you to be careful of not to do it, because it's easy to mix that up when you're first learning. All right, then they give you some examples. All right, so this is a change of base formula. You can write a log as an exponent or in exponential form. Seemed like they would have showed that before now. Let me go back and make sure I didn't pass it up. No, it just pops up here. Okay, so change of base formula. you can write the log as an exponential, okay, by moving it over. They're showing you that here. And then if you take the log of both sides, that will allow you to bring that exponent down, and then you can divide and get the value of x. So what they're showing you is that at the end of the day, they're going through the whole process and showing you how we arrived here. But the simple part of change of base is log of your evaluated number. So the bigger number that you see divided by log of your base. And they're showing you that they use natural log here. You get the same exact thing when you use log. So down here they're going to show you just a simplified change of base formula. So if you got log base b of x, log b goes on the bottom, log x comes on the top, and as long as the base of those new logs is the same, you will get the correct answer. So this is change of base, very important for you to know. And then so you have some pH scale problems. They'll show you those formulas when you get to them. You just have to click and you'll see those when we actually get there. And then they got a Richter scale problem as well. We'll show you that one when we get there. And I guess that's all they show you, but I feel like they're missing some very important parts. So let me show you some other things that are important that you need to be aware of. We're going to be simplifying logs. So there's a property that will cancel out a log. If you have log, whatever the base is, a, and then you're evaluating that log at a, and let's just say it has an exponent. Okay, log a will cancel out with a. That's kind of like the opposite. That will cancel it out, and you will just be left with 2. So there will be some problems that will intermix some of the expanding or condensing logs. So they showed you to expand it, but they also want you to go forward and backwards. So for example, let's just say I got log base a, and then I have a squared times 2x, for example. All right. The property that allows you to separate logs when you have multiplication inside, you would evaluate that. So this problem would become log base a of a squared, and then plus, because that's what happens when you do multiplication, this will be log base a of 2x. And then over here, there's a couple things you can do. You can either think about taking this 2 and bringing it out front, or you can just, it does the same thing when you cancel. But either way, that will divide out when you have the same base and the same evaluated number. This will just become 2, and then it'll be plus log a of 2x. So this is the goal. Sometimes you'll do several problems like this. Sometimes you might have to rewrite that number in exponential form so that you can do that. So just be aware of that canceling property, mainly that if you have a base and that same number is being evaluated, it basically cancels out that log and you're left with that exponent or whatever else you have. So with that, we'll just go ahead and jump over to Hogs and do some practice problems.